Welcome to the deep dive. Okay, so you've brought us this set of practice materials for what looks like a pretty serious credential, the VMware vSphere Foundation Administrator. That's the 2V0-16.25 exam.
That's the one?
Right. And our plan today isn't really just exam prep, is it? We want to use these questions, these technical scenarios, almost like a blueprint
Exactly.
to pull out the really core ideas, the fundamentals that make modern virtualization setups tick. Security, scaling, all that.
Yeah, that's spot on. I mean, obviously, this stuff is crucial if you're studying for the VCP. But for us today, we're treating it more like a snapshot of industry best practices, the non-negotiables for keeping things stable, secure, and ready to grow.
So we're looking beyond just the A, B, C, D options.
Right. We want to understand the why these answers point towards, high-performing VVF setups.
Okay. And we know the basics. 60 questions, 135 minutes, multiple choice. But you're saying the real goal is buried in the operational thinking behind it?
Yeah, I think so. Each correct answer kind of reveals something important about managing the compute, the storage, the security, and, importantly, the financial side, too, within the data center.
Because if a principle keeps popping up in the questions...
Then that tells you something, doesn't it? It signals where things tend to break or where security really needs to be tightened up. These sources kind of map out the risk areas.
Okay, let's unpack this. Let's start right at the beginning, square one, the physical server itself. So before an admin even thinks about installing ESXi, the hypervisor core, what's the absolute must-do first step? The check that has to happen for the physical hardware.
It sounds almost too basic, maybe, but it's probably the most critical gate. The physical host must meet the hardware compatibility list requirements, the HCL.
The HCL? Wait, isn't that just common sense, though? Like, if I buy a beefy server, all the parts work. Why does VMware make such a big deal about checking this list? Why is it like rule number one?
Well, because the entire stability of the whole platform kind of hinges on it. HCL compliance means every little piece, the specific CPU model, the firmware it's running, the storage controllers, the network cards, even the driver versions, it's all been rigorously tested and officially blessed by VMware.
Okay.
The sources hammer this because, look, if your system blue screens because of some dodgy driver or an unsupported HBA, the very first thing support's going to ask is it on the HCL?
Right. So it's not just about things working now. It's about support later. And maybe even liability. If it's not on the HCL, you're kind of flying solo if things go sideways.
Precisely. It's the foundation for enterprise-level reliability. You skip it, you lose that guarantee.
Okay, foundation solid. Stability.check.
Now let's jump ahead. Admins installed ESSS. Now they need to scale out. Big time. Dozens, maybe hundreds of new virtual machines, all configured the same way. What's the fastest, most consistent way to do that?
Right. The keywords there are fast and consistent. You need both.
Yeah.
The most efficient route, the standard best practice, is deploying from a VM template. A template. So I'm picturing like a golden image, a perfectly set up machine, maybe a Windows server, all patched, base apps installed, just frozen in time, ready to be copied.
That's a perfect way to think about it. Yeah.
Yeah.
It saves a massive amount of time compared to, say, cloning an existing VM over and over, or worse, installing the OS from scratch every single time. Using a template just cuts out the potential for human error during setup. All 50 or 100 or however many VMs are identical. That makes things like patching and ongoing management way easier down the road. It's standardization, basically. Makes templates the go-to for scaling up.
Okay, hardware's good, scaling methods sorted. Let's talk security. This is where virtualization really shines, isn't it? What's the absolute core security or maybe stability benefit that the whole idea is built on?
The bedrock concept here is isolation.
Isolation, big concept. How does VVF actually do that? What does it protect you from specifically?
Well, think of the hypervisor, that ESXi layer. It acts like a really strict bouncer or maybe a firewall sitting between all the running VMs. Isolation means that if one VM throws a wobbly crashes, gets hit with malware, whatever that failure stays put. It's contained entirely within that VM's virtual wall.
Oh, right.
It can't leak out or mess with the other VMs running on the same physical blocks.
So if I've got, say, 10 web server VMs on one piece of hardware and one gets hacked, the other 9 just keep on trucking, completely unaware.
Exactly that. I mean, I remember back in the day, before virtualization, isolation got really robust. A single bad driver or an OS crash could sometimes take down the entire host. Everything on it, gone. Just now. Thanks to isolation, a really bad day for one VM is just a bad day for that one VM, not the whole infrastructure.
So that's huge. Okay, so that's VM to VM isolation. But what about securing the management bits? Like the communication between vCenter server and all the ESXi hosts it manages? Why are admins always getting told to replace the SSL certificates on vCenter? Especially the default ones or expired ones.
Right. That's addressing a different, but equally critical, trust problem. It's about stopping a pretty common and dangerous security risk: man-in-the-middle attacks and unsecured HTTPS communication.
So if the certificates are expired or, say, the default self-signed ones are still there, what happens? Does communication just stop or become insecure?
Well, it could break, yeah. But worse, the traffic between vCenter and the host becomes vulnerable. Anyone listening on the network, a man in the middle, could potentially grab credentials or even inject malicious commands.
Ouch.
Because the systems can't properly verify who they're talking to. Replacing those certs with valid, trusted ones creates a secure, encrypted tunnel for all that critical management traffic. Authentication is key.
Okay, let's connect this to a basic security principle, least privilege. We've got a new team member. They need to be able to spin up new VMs from a template. Fair enough. But we absolutely cannot let them mess with the underlying cluster stuff, like adding hosts or changing vSAN settings. Where specifically in the VVF hierarchy do you apply their permissions to lock that down?
Right, least privilege 101. You never want to grant permissions too high up if you can help it. You need to apply that custom role at the most specific level possible that lets them do their job, but nothing more. So in this case, that means applying the role at the resource pool or folder level.
Ah, okay. So if their provision VM permission only exists on the, say, devtest VMs folder, they can work inside that folder. But because that folder lives underneath the cluster object in the hierarchy?
Exactly. They're automatically blocked from touching the cluster settings, the host configs, the VSAN stuff. Anything above that folder level.
Thanks, granular control.
That's the elegance of it. And what's fascinating here is how this takes that fundamental security theory, only give the permissions needed for the task right where they're needed, and maps it directly onto the infrastructure's object model. It enforces that separation of duties.
All right, security's tightened up. Let's get into tuning the engine a bit. We're looking at more specialized features now designed for managing performance and storage efficiency.
Yeah, this is where admins really start to squeeze value out of the hardware, making sure critical workloads get the resources they need when they need them.
Okay, let's start with the network. Quality of service, or QoS. Say you've got a super critical application running with vSphere fault tolerance, FT, the one that needs constant real-time sync traffic between hosts.
Right. Zero downtime tolerance.
Exactly. Now, what if the network link gets totally slammed by some massive backup job or VM migration happening at the same time? How do you guarantee on a vSphere distributed switch, VDS, that the FT traffic always gets priority no matter what?
That specific kind of guarantee, that prioritization, is handled by Network I/O Control, NIOC.
NIOC. So it's like an intelligent traffic cop specifically for the virtual network layer.
That's a great way to put it, yeah. You basically tell NIOC about different traffic types, emotion, management, storage, FT traffic, etc., and you assign them shares or limits. So even if that big backup job tries to hog 95% of the pipe, NIOC steps in, enforces the policy you set, and makes sure that critical low-latency FT traffic always gets its reserved slice of bandwidth. It keeps FT running smoothly, which is the whole point.
Makes sense. Okay, shifting from network pipes to storage. Specifically the modern stuff, VMware's latest storage architecture, vSAN Express Storage Architecture, ESA, it's built for the new world of all-flash high-speed hardware.
Break performance leap.
So with vSAN ESA, what's the key feature that helps with both storage efficiency and performance consistency? And it's apparently switched on by default in ESA.
Ah, you're talking about object space reservation.
OSR.
OSR.
Okay, I know ESA handles data differently than the older vSAN original storage architecture. Why is OSR important for ESA specifically?
Well, in ESA, OSR is about managing how physical space gets pre-allocated for the virtual machine objects. It helps ensure that when the system needs to write data, it can do it really quickly and efficiently without constantly juggling free space in the background.
Ah, okay. So it's about predictable performance.
Exactly. Because ESA is designed for maximum performance on flash, OSR helps optimize how that space is used right from the start. It contributes directly to those faster write speeds and the consistent performance ESA is known for. It's on by default because it's sort of integral to how ESA achieves that efficiency.
We've covered the foundations: stability, security, performance tuning. Let's zoom out now to the VCF operations layer. This is the high-level stuff: management, financial tracking, automation, the kind of things directors often care most about, right?
Absolutely. This is where the tech meets the business logic. The modern admin isn't just keeping servers running, they're managing resources as a service, often with financial implications.
Let's start right there with accountability. If a company needs to track resource usage, CPU, RAM, storage, and maybe assign costs back to different departments, charge back or maybe just show back, what feature in VCF operations handles that financial reporting piece?
That core function is delivered by costing and pricing.
Costing and pricing. So it's not just measuring usage, it's actually putting dollar figures or whatever currency against it, turning IT from just a cost center into something more like an internal provider.
Pretty much, yeah. The sources show that this feature lets you define rates for resources. So you can say CPU cost X per hour, RAM cost Y per GB. It gives that transparency needed for departmental budgets and showing the value IT provides. It's essential for demonstrating accountability.
Okay, speaking of higher level views, imagine an IT director. They don't want to wade through complex charts and logs. They just need one screen, a simple summary showing the overall health. Is CPU usage high? How's memory looking? Storage capacity? Any major alerts? That quick glance view, what's the best tool for that?
Yeah, for that specific need, a consolidated, easy-to-digest overview, the ideal feature is a custom dashboard within VCF operations.
A custom one, why not just a standard report?
Because custom is key here. It lets the admin build exactly the view the director needs, showing us those few critical KPIs: CPU, memory, storage, active alerts, whatever they care about.
Filters out the noise.
Precisely. It cuts through all the detailed operational metrics that the engineers need and just presents that simplified, maybe even traffic light style view of overall system health. Perfect for quick status checks.
Makes sense. Okay, last area, complexity and automation. This feels like where the admin role really shifts towards architecture. Let's say there's a really complex multi-step task, like provisioning a whole new vSphere cluster, or maybe rolling out complex storage policy changes across many VMs. And this needs to kick off automatically when something gets approved in an external system, like ServiceNow or some other ITSM tool. What VVF component actually handles executing that kind of complex automated workflow?
Right. That's a job for the VCF operations orchestrator.
Orchestrator. Sounds like the conductor, right? It takes the request from outside, manages all the steps in the right order across compute, storage, networking, and then reports back.
That's exactly its role. Think of it as the automation engine or the glue. It handles that intricate sequencing and integration needed to link VVF workflows with other tools, like your ITSM platform. It makes those really complex provisioning tasks, things that used to involve days of manual steps and coordination across teams, happen reliably, automatically, and everything gets logged. It's a huge part of modernizing IT operations.
And with that, we'll wrap up this deep dive. Thanks for joining us.
My pleasure.
We'll catch you next time.